And I want to highlight just a few things as a quick review, and then we'll step through it as well. Where'd that go? All right. So the first thing that we see is we've got our imports. And something that's worth just reminding you of in Python, when this script loads, when Uvicorn first imports our script because it's going to be hosting our Fast API app, when a Python script loads, Python's semantics are it's working top to bottom. This is generally true in interpreted languages. What makes languages, why you call them interpreted is because the interpreter is going line by line and evaluating as we go. And when we evaluate these first imports, execution will actually jump over to those modules, evaluate those modules line by line, and whatever's left in globals of those modules is what we're able to import. And so in the Fast API module, there's a global named Fast API and depends, and we're referencing those. Then we wind up binding those to the same definitions. And that's a little bit beyond our concern, but that does tie back into how does patching work? And patching relies on the same behavior, where it depends on the global variables that we have defined in a given module that we would ultimately want to patch over later. So execution jumps through those, and then we reach a class definition. Now, as you all learned as early as 1.10, when you reach a class definition, nothing happens. We register the fact that we now know what a greeting class is, and that type is now defined. And the constructor function is defined, but we don't have nothing to do with it right now. And then we reach this interesting convention where we're actually declaring a global variable named app and making a new instance of the Fast API framework or class. And this app global variable winds up getting used later on. And it gets used from the outside of our script. So you all have noticed when we run Uvicorn main, which let's just imagine this is main.py : app. Main is referring to the Python module, main.py : app is referring to the global variable app that we've defined here. If we had named this, server or greeting _ app or something like that, we would have to rename this part of the command as well when we go to start up our server. Similarly, whenever we use these decorators, so in Python this is called a decorator. In Java you might see this called an annotation. But when we use this decorator, this app that we're seeing there is actually referencing that global variable name, right? So we're actually calling a method on that object FastAPI.get. We'll learn about how these decorators work a little bit later, but effectively what happens when we, and I'm jumping ahead just a little bit, but when we get to that point, we're registering a route. So I'll say a little bit more about that when we get there, right? So all we've seen right now is we've hit this, we've got a new instance of a Fast API object. And I'm just going to real quickly delete what I've got, and let's start tracking our print statements. So when the server starts up, this was scenario 1. The first print statement that we see is we're defining routes, right? Execution continues on. We see another class definition. Once again, when we see a class definition, we know that nothing happens. We have, other than we've registered the existence of this class and this type, and we know what methods it has available, what instance variables, and so on, but we just skip over that. So we don't do anything with those print statements in init or create greeting yet. And then we reach this route definition. Now, what's happening here is behind the scenes, when we decorate a function with app.get or app.post, we're effectively saying the definition of the function that follows that is being passed to our Fast API app and saying, hey, this is the function I want you to call when this route gets matched. And we're registering that route greet name with this route handler, this greet function. You can think of this kind of like a controller, and in some other frameworks you would call this app our controller, and we're registering this particular route to be bound to this particular route handler, which is just a Python function. All right, but this is just a function definition, right? It's a function definition that's decorated. And that decoration does relate to the decorator pattern that you all learned about in 301. It's a slightly different form of it, but it's very similar in nature. Once that route gets registered, and now FastAPI is aware of it, we finally do reach this line here, print E routes defined, and I was happy to see that most of you all got the startup sequence print statements AE correct, right? Now, the second question, this was startup, was about handling a request. And the request was get method and /greet 423. Before I jump into that, any questions on what we've just talked through in this first tracing? All right. So when we receive a request, we did not write the logic that takes the HTTP request and tries to match it to one of our route handlers, right? That routing logic is part of the FastAPI framework. And the routing logic is going to try and match not only on the method, the HTTP method, but also the path. And the algorithm is we're going to start with our very first route defined and move one by one through each route that was registered with FastAPI and see if we have a match. The first match that we find, that's the route that gets matched. And that's important to remember for your current API design when you go to actually implementing it, because you might actually define a route accidentally that's very generic and catches all routes that have maybe a single part to it when you really wanted that to be defined later on. But nevertheless, we only have one route defined here, so we must be matching this one, the method matches, and the URL or the path matches as well, right? And this is a path substitution where 423 will be bound to this name. Now we see as the route parameters, there are two. And FastAPI must be taking care of injecting the correct values into these two parameters. The first we see is just the name, and that maps to this path parameter. So there's nothing really to do there. The second we see is a greeting service, and it uses the dependency injection capabilities that you all read about and worked on in class on Monday and then read about over the past 2 days, right? So what happens is before FastAPI can actually call this method or this function, it needs to have an instance of greeting service. So what it will do is it will go and construct an instance of greeting service behind the scenes. That would lead to this print B statement being printed. And then it now has behind the scenes an instance of greeting service and the route 423. So we jump into this particular method, right? And we would print D handling request. And I didn't mean that for that to be a different color. And then we see a call within that method to the create greeting method of this service. So that would cause execution to jump into this method definition. And from here, we would see C printed. And we would return back with a hello message. And then we would return an instance of the greeting model. And we have nothing else printed, right? Now, there's another request that comes in. And before I take questions on both of these, I want to give your table 30 seconds to imagine what happens on the second request, because there's kind of two ways to imagine of what might happen next. So greet 590, and then we'll discuss what actually happens and why when we come back. So you have 30 seconds to talk about what happens in this final request. 1, 2, 3, you go. 10 more seconds. All right, let's talk through this. What I'm going to have you do is, I'm curious on if we hold up a hand with 1 being they do the same thing and 2 being they do something different. And everyone just commit to 1 or 2 on 3. 1, 2, 3. Seeing a couple 1s, a couple 2s, mostly 1s. Yeah, so you can imagine this going either way, right? You can imagine fast API. This is a design decision that the API provider needs to make. And it turns out the default way is that it's going to reinstantiate a new service each time a request comes in. And one motivation for that is because in RESTful APIs, you can avoid a lot of problems if you treat each individual request as stateless. And you can imagine if you reuse that greeting service here, there's no state that's maintained here. There's no instance variables or things like that. But if you reuse that same object each time, and maybe there were some mutations to its state that happened while that request was being handled, the subsequent requests might be impacted by that state of a previous request. And that's harder to write predictable web services for. And if you want a great example of where that's done horribly, turn no other way than to Connect Carolina, where you can't have multiple tabs open and search for different courses at the same time. You have to go back to search for different terms, and there's statefulness in your requests that are happening when you're logged in as an individual user that break some of the web conventions you tend to expect. Like this should just work in multiple tabs without concern over where I'm at in other tabs. But nevertheless, the same process is stepped through here. So same idea. We come in, a new request, name now would be 590, but we still need a new service. So we go and we instantiate a new service. That would lead to B being printed out. And then Fast API is able to call this function. So it calls the function. Once it enters that function definition, D is printed out. We go and we call the create greeting method. So C is printed out. And then we return, and that's it, right? And so this would be as these requests come in, this would just be what's happening behind the scenes. Now you might think, well, what if we did want to have one object be instantiated for something like a greeting service rather than a new one each time and reuse that? Well, you have control, and there are techniques for doing that. You can have it either way, and that's thanks to the default way being, oh, we're just going to call. It's actually kind of clever. It just calls the function that you're depending on. So in this case, the function is the constructor of greeting service, and that would get called here. But you could also define a factory function or a singleton, like you all learned about in 301, that maintains only one instance in global memory at any given time and reuses that same object. And there are cases where you might want to do that as well. Questions on this example? Having some comfort with knowing some of these life cycle sequences of what happens when this script first loads, what are the steps that happen as dependencies get injected, and it turns out you can actually have chains of dependency injection, and you'll see this as being very valuable, actually. So greeting service could depend on some greeting database or greeting store that it needs to load, and that can be loaded automatically through dependency injection. And behind the scenes, Fast API has a directed acyclic graph of knowing what does it need to do in order to actually successfully inject the dependencies that are needed, and it would work through constructing your objects in the correct order and bringing them all together. Another benefit of this type of design, which you all get some more practice with soon, is that because these are just parameters to a function, you're able to mock those parameters in test and very easily override them and substitute them with test doubles to isolate a route handler from underlying services and so on. So there's architectural benefits in dependency injection as well. All right. Before we move on to the next phase, I want to give one piece of advice for these types of exercises in class. And I've seen it in a couple isolated instances. I'm not trying to call anybody out. I understand the what's the word I'm looking for? I understand the draw to this, But when you see an example like this, and we have like 5 minutes to discuss as a table, please do not copy this and paste it into ChatGPT and ask for what's going on. Engage those brain cells and struggle through talking through it. Even if what you're saying winds up being wrong, I promise you you'll learn more and it'll stay with you longer than dumping it in a chat and asking for what is the order this gets evaluated in. Right? I understand the urge, but when you feel that particular urge, in scenarios like this, we really want you to pause and think through it. All right. Nice work with that. I actually think we were talking as a group up here. I was curious how you all would compare to last spring. And I think looking around and walking around and looking at the boards, you all did better than last spring. So props to 210, 211, 301, and 110 that you all came up through. All right. So now, before you all get to working as pairs on your API design, I want to give you a couple pointers for how to approach this. One, we kind of intentionally dump a lot of information on you, the stories and then some things about documentation, and we don't give you all the details like you might expect. Part of the design process is really stubbing your toe on some things and realizing, oh wait, I didn't think through that particular case, or maybe I needed that extra field in my model, things like that. So as you're individually starting with thinking about your APIs, I would encourage just focusing on a rough outline. What are the routes I need? What are the models I need? Don't worry too deeply about the documentation details that we're asking and expecting here. Those can come later. Once you've convinced yourself that you've got the routes for the stories and the models have the data that they need to be able to follow them, and you will need to modify or create new models to satisfy all of the stories. Once you and your partner are able to settle on a direction, be sure you have pushed your initial design branches first. So like part of the submission for this, which will go live later this afternoon, is we want to see the individual design branches. Then you can go through and add, when you bring them together and decide on a final structure, that's where I would recommend spending more time adding the documentation details. And as you're adding those details, I would encourage strongly refreshing your API docs in your web browser, because you'll be able to see those details filling in and make a stronger connection between what it is that you're doing and understanding why you're doing it, right? And I would recommend, while you're working together and pair programming on that singular API that's your team API, work in a whip branch, practice some of the pair programming techniques that you read about, navigator, driver, however you want to do it, ping pong, try out a few different ones, have fun with it. But do make small commits as you make progress, and it's easy to revert things as you need. All right? So with that, I'm going to turn it over to you all for a bit to work on your APIs together and make progress. And then we'll come back for just a few notes on what's next. All right, I'm going to interrupt. Glad to hear progress being made. I want to make a few points of things that I've seen and questions that have come up from around. One question that's come up that was actually a surprise that I've never seen before, but when someone tried to push their repository, I've now seen it in 2 instances, push their repository to your team repository, it was met with an OAuth failure. OAuth is the system that authenticates requests that you make from your machine to GitHub. And it's a little unclear what went wrong in those requests, but the fix was effectively from within VS Code, log out of your GitHub account. So in the bottom left corner of VS Code, you'll see a profile icon. You can log out and log back in. You only need to do that if you see this problem, but that fixed it in at least one of the cases and hopefully in both of them. The other thing I just want to mention, if you've never used a link shortener before, you will have access to one if you want to understand what this is by going to go.unc.edu. And let's say I wanted to make a shortened link to a website like chrisjordan.com. I could do that. And I can, this service automatically chooses a randomized short URL, but I can change the short URL to be something like KJ. Maybe that's not taken, we'll see. And there's some other features that it has, like expiration date and things like that. But when I press create short URL, now if we go to go.unc.edu/kj, it goes to my very outdated website. And that's so the slug or the vanity URL in your particular application or API is just this one piece of the path following some host name. And then the target is the URL that you're trying to redirect to. Bitly and other services popularized this some time ago, but that's effectively what we're building an API for. All right, the last thing I want to mention before I turn it over to you all to plan when you're going to get together with your partner and think about next steps, and you'll have a couple minutes for that, is to mention that so we've pretty much wrapped up grading. There's just one person with medical conditions that led to not being able to take the quiz last week needs to take it, and then we'll release them. But we saw that there is some confusion around patching in the integration test. So we're going to have another opportunity to work on that. I think that's something that we didn't cover well enough. So you'll have another opportunity to do so and to get some practice with it in the context of working with Fast API. So the next reading, which is due Friday, is on how do we actually unit integration test and end-to-end test these API routes. You'll need to do that as part of part 2 of the current task. Part 1 is just come up with the API design. You're not implementing anything. And the instructions for part 2 are still to come. We're still aiming for tomorrow night to try and have your API design submitted, and that I'll send out an announcement later with that submission going live, as well as how to submit this next reading. We'll get some practice with this, and hopefully we can clear up some misconceptions around integration testing versus unit testing and get more comfort working with mocks and things like that, which are really helpful when we're using dependency injection. So I'll turn it over to you all. That's all we have for today, but do plan with your neighbor how you want to continue making progress on this and plans for submission. And we'll see you on Friday.